Alright, time for another DraftPhysics.com, debatephysics.com also, which I have changed a little. I mean, I just put the videos, the more recent videos that I thought were pretty good near the top, the simulation video, the text I wrote, and stuff like that. So anyway, just to make it a little, the spring video, which is a really important one in the case of a comment that was left. So I'll go over some of that as a continuation from the last video I made. There, we can slide that over a little bit. This is the simple comparison between a 5 mass going 10 and a 10 mass going 5. Their argument is it's the same exact energy. Okay, they both have the same number of joules, and that somehow the tug of war would be oh no, they have a different number of joules. Should start the damn video over. Anyway, yes, the 5 going 10 has twice as many joules of energy, twice as much energy as the 10 mass going 5. And obviously the momentums are exactly the same. And so, no, they would basically be a tie. Momentum would win, momentum would prove itself to be real, and kinetic energy would prove that half the energy is missing. Okay, it's going to disappear again. So just like when you add the 5 mass to the 5 mass going 10, and I add 5 mass to it gracefully, and I lose half the kinetic energy, it's the same argument. It's not going to show up anywhere. There's not going to be any evidence that kinetic energy is real. So what I'm asking, is show me an experiment where the kinetic energy is actually collected, that's shown to be actually real. All right, so pushing that further, if I was to make them have the same joules of energy, I could make the mass a 20 mass going 5. So they're saying that a 20 mass going 5, that is something 4 times heavier, going half the speed, is the same energy, okay, as a 5 mass going 10. And I think you know which one's going to win the tug of war. It weighs 4 times as much and it's going half the speed. It's going to decisively win. All right, so if you made them stick to each other, that is, you move the if you move the 20 mass going 5 and had the 5 mass stick to it, you know what's going to happen. Well, yeah, you still have to have it go 10 into it. But anyway, you know if that collision takes place. So one collides into the other and they stick. Okay, you make it as graceful as sticking as possible. You know which one's going to win. You know, it's not even an argument. And then if I made it 31 kilograms to 4v, okay, so, 4 velocity and 31 kilograms. So 31 kilograms versus 5 kilograms. More than 6 times heavier. And I could go 55 and 3. And I could go 124 and 2. So 1/5 the velocity, but 124 kilograms. I mean, a gigantic increase in the weight. And then ultimately 500 kilograms going 1v. Their argument is that has the same energy, the same capacity to smash or crush something as a 5 mass going 10. 500 kilograms. 10 times more weight. I mean, it's just... No, it's not 10 times. It's 5. It's 500. It's 100 times more weight. I mean, does this make any sense? It's junk science. Okay. All right. So I wanted to start with that just because I still had that on the screen. So I said, okay, what the hell? Let's start with that. And now I'll do comments. All right, so Mophead says, what kind of evidence would you like to see that acceleration is m divided by squared, seconds squared? It's like saying, what kind of evidence do you want to see of hobgoblins? Anything will do. If you have some piece of evidence, what my simple argument is there's zero. Ooh, that's the wrong pen. That isn't going to work. I have to use this one. It should still be erasable. Well, not very erasable. All right, have to fix that. Yeah. Yeah, don't want to make any permanent messes. Anyway, all right, so let's say I have a velocity. Okay, so I've established a velocity. I can make a vector for that velocity, and we can say it's 20. Okay, and we'll say, kilometers per second. Is that what those are the units we put it in? So we have something going 20 kilometers per second, and I'm going to add acceleration. I'm going to accelerate. Well, I would draw the vector exactly the same, right? So 9.8, okay. All right, meters per second. This is supposed to be meters per second. My bad. Okay. So I'm saying, okay, that's all I would do. I would just write this vector in the same units as this vector. It should be half, a little less than half, obviously, so I drew it a little too long. But you should be able to get, let me just fix it. You should be able to get over it. That's all I would do. I just add the vector. It's 9.8 meters per second. Now you show me what 9.8 meters per second squared looks like. So if I'm going to add per second 9.8 meters per second squared, what does that vector look like? How do I add it? How do I add meters per second squared? That's all I'm asking you. I'm saying there's no way to do it. This is completely superfluous. It can't mean a damn thing. Because the only thing there is adding to the velocity. You're just adding. This is the acceleration. There's no difference between the velocity and the acceleration. Once you've added it, it's exactly the same as velocity. Because it is a velocity. That's all you're doing. You're adding or subtracting a velocity. You're not doing anything special. There's no such thing as acceleration power. No. It's just an added velocity. All it is velocity. It's nothing more than adding velocities. So you explain to me why and what the difference would be. Show me. Can you draw anything? Can you show anything? No, you can't. You're completely incapable of engaging in this conversation in any kind of reasonable manner. So you can't show me because you can't draw anything. So what are you going to do? But what are you going to do? You're going to make the vector, you're just going to what? You're going to draw the same line and say it has superpowers? Super hobgoblin powers? What's the difference? So you explain to me, what does a 9.8 meters per second squared physically look like in any kind of force diagram? How do I draw the difference between 9.8 meters per 1 second, which it actually is, just like it's 60 miles per 1 hour? You say 60 miles per hour. You don't say something else. Right? 60 miles an hour. People even say that. It's, 9.8 meters a second. A second. 1 second. Yeah, okay. Squaring a 1, I'm trying to point out to you, is idiotic. Can't do anything. Squared 1 doesn't work. Can you understand? That's jargon. That's, it's not mathematics. It's crapomatics. It's fool the dupes-omatics. Doesn't have anything to do with doing science. Squaring a 1 is not science. For no reason. Just for the fun of it. Yeah, okay. Too stupid, you fuck. What a jackass comment. Ugh. So I'm just so close to being done with you, jackass. All right, so now he's linked to a Dispar video and a Falwell video. So I'll illustrate those and just point out, look, there's no point. You won't accept a single premise, and you won't argue how the ones I'm stating as facts are facts. You won't prove them wrong. You won't prove how anything I'm saying is incorrect about how springs work and how gravity works and how friction works. So we don't agree on those elemental functions. And so we need experiments that prove the case on those elemental things. And without them, there's just nothing to argue. You have your religion. I'm going to call it what it is, a religion, an unevidenced pile of shit. You've had 300 years to contrive it, and you can't show me any evidence. And I'm saying I can illustrate the functions of the universe in a model that's completely consistent. Unlike your silly theories of bent space and quantum mechanics and all this wooey nonsense, mine all fits together. Yours doesn't. So I'm going to win the Occam Razor shortest distance to the solution award. So fuck you. But these experiments should be done. I'm the one advocating experiments should be done. He overtly says, who the fuck cares? Experiments, who cares? I'm going to read it. He says it. You know. So this is the menace to science. Science is experiments. That's the only way you can do this deduction thing is you got to test things. You have to, you know, do the ballistics test and do the fingerprint test and do the genetic test. You have to do the tests to build the evidence. Asshole. Alright, so he says I could link to some collisions experiments showing how momentum is conserved. Well, do it. But he won't. He's not going to link to any that are credible. So the argument is they have to be credible. And he won't link to any that are credible. But you have already seen them. And it didn't change your mind. Well, why? Yes, bullshit isn't going to change my mind. I know the difference between evidence and smevidence. Okay, denting clay with round objects, I've already demonstrated. Do you think that's a good experiment? Do you think that's scientifically credible and sensible? That somehow that'll give you a correct answer? Because, yes, a round surface is perfectly linear. You know, it's the same on the sides as it is on the bottom and everything. I mean, vertical is the same as horizontal, right? I mean, horizontal surface, vertical surface, same damn difference, right? Point or flat part. Well, what's the difference? You know, it's just a tilted point, right? I mean, you know, a point and a flat part, well, it's the same thing, right? It's a square, right? If I let it fall on its pointy end, same difference if it lands on the flat end, right? Yeah, you're an idiot. All right, here are some weight drop experiments. Well, that's not what they are. One of them is a drop, and one of them is a launching things with springs again. And we've already been over the spring argument, so that one's dead in my opinion, just like the wheel problem. You know, the fact that you can't figure out what angular momentum is, and that it has to be calculated as part of something's momentum when you're going to crash something. You have to also add the angular momentum of the wheels and the axles. It's important. Okay. Yeah. All right, so... The disc bar, I hadn't seen these before, but I don't pay any attention to compulsive liars. I mean, people who leave up videos that are he knows to be inaccurate and wrong, you know, and he leaves the video up as if he's making a proof argument when he knows it's wrong. The physics is wrong. All right, so he's basically just put a clothespin, okay, on a steel rod. And he's going to hit it, okay, with weights from different heights. And so, obviously, we're just back to the friction argument. So all you have first is just a little bit of static friction. And then after that, once you break the static friction, it's just, again, something that's putting pressure, a constant pressure, on a surface. So it's not much different than the gravity argument. And the faster you move it across the surface, the less pressure per inch of surface will be applied. So we're back just to the same argument again. This is just going to basically be a time-dependent force because the pressure is force times time, not something else. And so you're just stuck with the same argument about friction. That yes, the faster you move it, the faster you slide it, the less friction there is because, you know, per inch. Because the movement breaks the contact. And so it's like a ball bearings. They're much more efficient at higher speeds. So if you can get something spinning very fast, the bearings almost waste no energy. They don't get as hot. They don't do a lot of things. They don't vibrate. They don't do a lot of things they would do at slow speeds. So we know that friction changes with velocity. So you can't do friction experiments unless you're going to measure the absolute heat. So if you're not going to measure the absolute heat, there's no point. And that's why Joule is actually famous. It was because he discovered that. So again, you just don't pay any attention to the history. The history is that Joule wanted to be able to test a steam engine against an electric engine motor. And he discovered that, gee, there's no way to do this test, right? We haven't really figured out a way where I can create run the machine, collect its horsepower, and figure out which one is collecting more horsepower per the amount of fuel I had to put in. And so there was no good way to test that, because all of these tests have these stupid flaws. I can't drag things across the ground. I can't do this, because they're not linear tests. They're not fair tests. And so that's why he came up with the idea of, basically creating an insulated vessel and just measuring the absolute heat, because that he knew he could do. He could convert all of the energy into heat and then measure the amount of heat. So essentially he would waste all of the energy, but he would waste it all in a container, and then he could measure what was in the container. All right. So it's all quite sensible. Now the problem with Joules' experiments is he did a bunch of gravity experiments. So he just broke the whole system, because he ended up creating the heat by dropping things in gravity, which is the same argument about the fact that it's not linear. All right, you don't gain energy per distance. You gain energy per unit of time. So if you don't understand that, you're going to get wrong answers. All right. So that was the first experiment. Useless, I would argue. No proof that putting a clothespin on, like this pen, I could put a clothespin on it. There's absolutely no evidence that it's the same friction no matter what speed I move the clothespin. No evidence. We don't have any proof of that. So useless. All right. Second experiment. All right. Editing problem. Anyway, it's a second experiment. It's going to be about springs, but so I might as well show this, the website. So this one here is the spring video. It says right there, The Truth About Springs. So you watch that, you get the whole bigger story. I'll give you a part of the story here. And this first link is to the written stuff, and then the charge simulation is right down here. So, lots of videos, and then all the 5-minute videos are down below. So anyway, back to the comments. All right, so we should be able to just click on that, right? And that should be the comments. All right, so so the second link he provides is to a Falwell experiment. So another guy just bent on cheating wherever possible, and so I didn't watch it, but it's I saw the basic function. And so what he's basically doing is just doing this spring launching thing. So just compress the spring and launch objects. And obviously the expectation is that twice the compression of the spring is going to be twice the launching power. And the argument is springs can't do that. Okay, unless it's the same weight and it's going to move the same velocity. Unless it's going to move the same velocity. That is, so if you gave the heavier object twice the compression and then gave the lighter object half the compression, then they'd move at the same speed, right? And then you'd have the spring could give the same percentage of its energy to the objects. But every time you change the speed at which you move something, you can understand there's a moment where the spring's expanding and it's pushing. And there's a moment where the object leaves the spring, but the spring is still moving in the same direction it was pushing. Springs don't push and then just stop, and the object flies off because the spring stopped. That doesn't happen. The spring goes out and then it slows down, and then it springs back. So you can understand the spring hasn't even come close to starting to slow down when the object's leaving. The object's leaving as the spring is still accelerating. So the spring hasn't even started to complete its task. So it's always inefficient. And it just depends on how inefficient it's going to be. So the lighter the object, the more inefficient, because the faster the spring is still moving when the object leaves. So I have the same spring, and I move the spring with twice the velocity, presumably. You can understand, well, when the object leaves, the spring is going to have a ton of energy still in it, because it's going very fast. And with a heavy object, it's going to have very little energy left in it because it's going very slow. So you can understand a huge difference. The spring can't give actually an object twice the velocity because it can't get the energy in. It can't go fast enough to push it at the fast speed and then decelerate and somehow still give the object that extra energy created by the deceleration. So you can just sort of understand it can't just stop. It keeps moving, meaning it still has energy to give, and it can't give it. All right. So obviously when the spring is wobbling after the experiment, you know, well, that wobble has to be the momentum that went in. The wobble can't be for free. So the spring oscillating is obviously some portion of the energy that was in the compression of the spring, and you haven't put it into the object. So the more the spring is oscillating, the more energy you know didn't go into the object. And it's obviously going to oscillate more when it was moving something fast than when it's moving something slow. So it's just such a simple argument. So all of these experiments are invalid. If you want to go twice the velocity, you have to measure twice the velocity. That is, you have to have some mechanism to measure its velocity. You can't assume because it's twice the spring compression, it's going to be twice the velocity. Because it's not. Okay, it's just as simple as that. It can't. The springs don't work. And you can see this, like, I didn't realize this, but when we were having these arguments and all this crap, somewhere I read that a tennis ball is only 75% efficient. So with each bounce, it's losing 25%. So that's why it only bounces like 4 times and then it's done. Because it's losing a huge percentage of the energy with each bounce. So they're not very efficient. And so every spring is going to be a little different in terms of how much energy it's going to lose. But obviously when the spring is moving twice the speed, you understand it's going to be twice the energy still left in the spring. It's going to be a lot of energy still left in the spring. All right. So I really shouldn't have to go any further with that argument. I don't think I should. Yeah, that's probably it. It's on the website. Blah, 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 blah. All right, so continuing with the comments. It's not easy to find direct evidence in peer-reviewed literature because the conclusive experimental data was gathered hundreds of years ago. So this is just a lie. No, it wasn't. Leibniz never tested 4 pounds dropped 1 foot and 1 pound dropped 4 feet. So where was this experimental data collected? And if you're going to go all the way back to Newton, I mean, if you're going to go all the way back to 350 years ago and tell me that was good enough technology to do these experiments, I'm just going to laugh in your face and say, fuck you. I mean, it's too ridiculous for you to argue that science did the experiments back in the Stone Age and therefore it doesn't need to do them with all this precise instrumentation. You know, it precisely weighed things 1,000 years ago. Fuck you. All right. Research is focused on things we don't know. So again, you're just saying you all believe in God and that's all you need. You're all faith-based believers and you don't need to prove anything. You don't need to show evidence. I'm saying it's unreasonable of you to make any arguments about my reasonableness or my intelligence if your argument is, I didn't need any evidence, so you shouldn't need evidence. No, I don't believe in believing without evidence. I want to see it, okay? Don't tell me there's a quark. Show me there's a quark. Show me what evidence made you believe in this nonsense. You believe in absolute nonsense, and you can't show me the evidence that convinced you. So what convinced you? They say so. That's what convinced you. That's all you have as an argument, is the classic religious argument is, well, they wrote it in that thing, the book called the Bible-y thing, and has some pretty pictures in it, and so, yeah, the story says so. Why isn't the story the truth? That's all you're saying, you shit. All right, anyway. An experiment showing that classical mechanics work is done in classic rooms by teachers and students. So, and I've already pointed out that if the teachers don't understand how springs work, I guess the students aren't going to be able to figure it out. So, I mean, is that fair? No, that's not fair. So you have to understand the variables in anything any experiment you're doing. And you're just pretending you don't have to. So if Brozo does experiments denting clay with round objects and claims it's proving, okay, some fact. So if I do an experiment where I use a pointed arrow and it goes into a surface deeper, and I claim pointing arrows makes the arrow have more energy, you would say I'm doing good science. Because all I have to do is do a demonstration and show that pointed arrows work. They do go much further. So obviously they must have more energy. And that's all you're doing. You're saying, here, I can make it look like. And you're not smart enough to figure out, that's not, it looks like, but it isn't is like. Just like I could do with wave particle and the whole perversion of the double slit experiment. It doesn't really look like. So a single slit in water doesn't look anything like a single slit in light. So you just pretend. Okay. You just lie is what you're doing. All right. But you don't actually need any evidence. So right there, fuck you. So I mean, that's a blockable statement. I think it is. Okay. Because you already know everything you need to know. So absolute bullshit. For example, you concede. No, I didn't concede anything to your nonsense. So this is another one of his lies. Okay. Again, that charge in momentum equals force times time. The change in momentum equals force times time. When did I say that? The change in your momentum is force times time? No, your change in momentum is your force. The force is momentum. I don't need to multiply it by any time factors. It's a net product. There's no circumstance in the real world where there's a constant force. So again, you're going to keep arguing as if there's some, like this constant force stuff comes up all over the place. It doesn't come up anywhere. It doesn't exist anywhere. Except in gravity. Realistically. Because there's no other force except for like electricity and light photons moving the speed of light. You know. You're such a, this is such bullshit. There you go. I don't know where you go with that. So you're arguing that it's force times distance. So I don't understand. You're conceding my argument. Fucktard. Anyway, if that's true, which it is, then force times distance must be proportional to change in mv squared. How so? It's only true in gravity. You still can't figure this out. It's only true in the circumstance where you're acquiring velocity constantly by an acceleration being added every single unit of time. It's only true in that one case. And again, if I use wind or I use some other force, they're not infinitely fast. So there's going to be a huge change in how much pressure is going to be applied dependent on your velocity. So you're just not paying any attention here to reality. Okay. Let's see. So yeah, I didn't make any argument. It's obviously if you square the amount of time, you'll get the amount of distance. And it's only because you're acquiring velocity, and the velocity is sustained. So you get the 9.8 meters, you get to keep that velocity. And then you get another 9.8. That means you're going 4 units of distance every second. And then the third second, you gain 5. So now you're going 9 units of distance. And then the fourth second, you gain another 9 plus the 16. So now you got whatever, it's 25. I don't know. So you just keep adding the extra, okay? And it makes perfectly good sense. And it works fine. So that's the real formula. You're conceding it works. MGT works. Okay. Another consequence is the two objects with the same momentum can do different amounts of work like springs. Okay, there's absolutely no evidence of that. So again, this is your failure. Show me. So until you show that that's true, Hooke's law says it's not true. Okay, so you're going to prove Hooke's law not to be a law. Well, go ahead. You should be able to get a Nobel Prize for that. All right. So it doesn't make sense. You think momentum is energy. To you, it doesn't make sense. To me, it doesn't make any sense to think anything other, because in every fucking experiment, as I said before, momentum never fails to get a right answer. Momentum never will cheat you or deceive you. If you follow the momentum, you're not going to go wrong. Feel free to disagree, but you don't have any arguments. Well, I have all of these arguments. I have the lever. I have the ballistic pendulum. I have the train argument, the tug of war examples. I have, there's 12 of them. Okay, so yeah, I can't remember them all right now. But you could do gears. You can do it in so many different ways that prove you don't have any evidence that it never works. A hose, just crank the hose and I can make more energy. Bullshit, I can. Okay. All right. Oh, a quote from Newton. Good. Finally, a quote from Newton. The quantity of motion which is collected by taking the sum of the motion. So, look, we've already seen this already. What do you think he meant? I mean, you're interpreting this statement. So, again, this is a problem with the whole fucking Latin crap, which is really irritating. Taking the sum of the motions directed towards the same parts. So, what does that mean? Going the same direction. And the difference of those that are in different contrary parts. Yeah. Suffers no change from the action of the bodies among themselves. So he's saying whatever goes in, the same thing comes out. So you're interpreting that as saying something other than that. That's how I'm interpreting. He's saying no matter what's in the system, it always has that in the system. There's always that much motion in the system. So it doesn't matter whether it's going this way, it doesn't matter whether it's going this way, it doesn't matter whether it's going that way. Whenever something happens, it's always going to be the same amount of momentum moving. And the only thing you can change is the directions. Who cares what direction it's going? All right. This is how Newton understood quantity of motion or momentum. Your idea of momentum dates back to medieval time. Okay, I'm just going to block it now. We're all done. It's just too pathetic. We've argued this over and over. They had 100-year controversy. It's been written about. It is not a fable that this fucking subject was a real subject for 100 fucking years, and that it wasn't resolved with evidence. It was resolved with a fucking show experiments, for fuck's sake. So you want to pretend there was no vis visa controversy? The French government didn't sponsor a contest to prove one way or the other which one was energy? Yeah, all of that happened, fuckhead. And it didn't happen in the medieval times, fuckhead. It happened after Newton and after Leibniz and after Huygens, fuckhead. Ugh, you lying shit. Alright, so we'll get rid of that hoodie crap. We don't really need that shit. Alright. Just commenters. Alright, so there probably is an email from the asshole. I did see something, so I'll see. But there's no debate. There's no, he's way off the subject still. So I'm done with you, Jason. So you can send emails, but I'm not going to bother reading them because you're not adding any value here at all. Okay, you're just wasting my goddamn fucking time. So he says, no, I did not give, no, you did not give a force value. So I'm not even going to read any further, frankly. What are you talking about? All right, I'll read it. Or the acceleration to calculate the force of the tug of war, for example. I gave you the mass and the velocities for motherfucking sake. There's no argument here. I gave them to you. They're written right on, look at the beginning of this video, you fuckhead. They're written right on the fucking board, you fucking liar. All right, I can't read this shit. I just can't do it. All right, I'll be done with this asshole. Let's see, Gary, you can't even spell my name correctly, you fucking cunt. Anyway, you don't even have the basic, okay, fuck this guy. So I'll just put you on the block list. Don't bother anymore. Okay, we're done with you. Too pathetic. I mean, what a waste of motherfucking time. So I'll see if there's something I can add to the video, but I probably guess, it's probably a half hour's worth, so we'll just leave it there. But nothing on the subjects of physics. So nothing demonstrating any physical examples, nothing showing that, 500 pounds moving 1 mile an hour is the same as 5 pounds going 10 miles an hour. Same energy. Both of them could pull a boat the same speed. Both of them could do the same work in the world. Bullshit. Yeah. God, it's just so fucking pathetic. They just keep defending this fucking religion.